I'm so dumb.
No, you're not. It's just a brain fart moment.
Okay, is it guaranteed that these questions won't be on the next one
No.
because we already answered them?
No.
Or it can be anything?
It could be anything. It's a random generator, so you might see a question again.
Like rate these?
Yep. All right. All right. So today we're going to open up to page 39. We're actually going to do this section together. I thought that this would be most appropriate. One, because it's really short. Two, because it's really easy. And three, we're going to get it so well that we don't really need a whole class period to assess our understanding. Okay? So I'm thinking that we're going to get done with this so fast, you're going to have so much time afterwards that you're going to be able to finish the homework assignment. How does that sound? Sounds good? Okay. So on page 39, we're going to take a look at limits of exponential functions. We looked at exponential functions exhaustively last year. Okay, we went through so many different properties and rules and different traits, growth, decay, all that stuff. So we're going to revisit that in this chart, and then we're going to take a look at actually some of the limits. So the beginning graph of an exponential function, typically an exponential function looks as such: a times b to a power plus c. What does the c represent? Yeah, Christian?
A constant.
A constant, which is what in terms of the graph? Yeah. The horizontal asymptote. Perfect. Okay. So both are correct. Okay. So if our b value, notice b stands for base, if the base is in between 0 and 1, okay, and this letter c is the asymptote, how would we classify or draw an exponential graph? Go to Nish. Decay. Goes towards the asymptote. So as you read a graph from left to right, it goes towards the asymptote. What if the base is bigger than 1? Growth. So as we go to the right, the graph goes up. All right, those are basic beginning exponential graphs. Now they can start to change the moment we throw in some transformations. Okay, so we're specifically going to take a look at negatives, like how we can flip this graph. So if we were to throw a negative on the outside, that would look like negative a times b to the x plus c. That's indicative of an x-axis flip or reflection. How would that change this beginning decay graph? Can you describe it? The x-axis, which would in turn flip it over the asymptote as well, because the asymptote is horizontal just like the x-axis is horizontal. So if we flip it over, it would now look like that. The horizontal asymptote is still at C, but instead of you being above it, you're now below it because you flipped it. Still decay?
No.
Change to growth. Yep. As you go to the right, it goes away from the asymptote. Okay, so it's still growth. It's growing down, okay, but it's still growing. So very similarly, if we flip the next one, wait, I drew that in wrong. My bad.
I had it the right way. And then
I looked at the wrong one on my paper.
Let's go. Lego man.
All right, it's still decay. I got ahead of myself. I did the next one.
He was just reading the board. Yeah. I was a little confused now.
Is that better? Are we all on? We're all on the same page. Mrs. Bauer is not off the train today, or anymore at least. Okay. So a negative on the outside flips it upside down. Let's check out the next one. Negative on the inside, that would be in the power spot with the x. That's going to flip our beginning graph left and right. So if we took the beginning graph from the top and flipped it left and right, it would now be towards the asymptote on the left-hand side, and it would go up on the right-hand side. Now it's growth. Yep. All right, so what if our base is bigger than 1? If we flip this beginning graph left and right, changes to decay.
Oh, shit.
All right, so we can flip upside down, we can flip left and right. And for the last one, what if we want to do both? Okay, so we want to take the beginning graph, the one at the very top, and if we were to flip it left and right, and then upside down, what would it look like? The asymptote's still at C. How would you describe it if we flip it both ways? Growth. So growth either goes up or it goes down like that. It's going to go down. Yep. There we go. Okay, and then if the base is bigger than 1, we're going to take the beginning graph, flip it both ways. Asymptote's still at C. What's it going to look like? Decay below the asymptote. Okay. I'm hoping some bells are ringing from last year. We did this quite often. Okay, looking at those reflections. So what we're going to do is, now that we're familiar with how these changes operate, okay, these flips or negatives, we're going to use them to our advantage when it comes time to evaluate some limits. All right, so let's flip to the next page. Now, starting things off kind of easy, we're giving you the equation and the graph, so we can use whatever we need to help us evaluate these limits. Typically, we try substitution first, okay, always our best bet. But notice how these limits we're trying to find here, they're going towards negative or positive infinity. I think substituting in infinity might get a little confusing for us. Would you agree? Because it's not a number like we're used to. So for now, we're just going to take a look at the graph that's provided for us. If we go forever to the left on this graph, what would our limit value be? Infinity. Good. And if we go forever to the right? Negative 2. How would you classify this exponential function, growth or decay? Decay. Good. All right, let's try the next one. If we go forever to the left, we'll approach negative 2. If we go forever to the right, infinity, growth or decay graph? Growth. Okay. Next one, forever to the left. Negative infinity, forever to the right. Negative 1, growth or decay? Decay. All right, and last one, forever to the left. 2, forever in unison. Forever to the right. Infinity, growth or decay?
Growth.
Just Christian. Okay, growth. Good. All right, so I want you for a second to take a look at these limit statements. We were only looking at the end behavior, going all the way to the left and all the way to the right. How would you classify these outcomes? Take a look at all of the answers. What do they represent? Limits. What does the infinity represent? We go up to the left. Okay, what did this negative 2 represent? Asymptote. What did this negative 2 represent?
Asymptote.
That negative 1?
Asymptote.
That 2?
Asymptote.
Asymptote. So if you take a look at the outcomes for these exponential functions, you're either going to get a positive infinity, a negative infinity, or what? The asymptote value. Okay, so we have 3 possibilities for limit values. Okay, but this is only going towards the ends of the graph, like all the way to the left and all the way to the right. So what we're going to do is make a little side note at the bottom here. If we can identify it as exponential growth, what would the limit values look like? And if we can identify it as exponential decay, what would the limit values look like? So let's check out as x approaches negative infinity and as x approaches positive infinity. All right, now we labeled the graphs above as decay or growth, so you can reference those if you have to. Or maybe we can just think about these, because as you go to the right, whether you approach the asymptote or go away from the asymptote, that can distinguish growth or decay. So if we can identify a growth graph, what would we be doing or approaching all the way to the left? That's the asymptote. Okay, take a look at our examples. So the two on the right. As we go to the left, we approached those asymptote values. So if we're approaching the asymptote on the left, what does that mean we're doing on the right? We're going either up or down, okay, depending on the growth direction. What about the decay ones? If you think about a decay graph, what are you doing all the way to the left? That's the plus or minus infinity, okay? Take a look on your paper. We either went up or down, depending on the direction, which means if we're going up or down on the left, what are we doing on the right? That approaches the horizontal asymptote, okay? So if we can determine growth versus decay, and are we above or below the asymptote, okay, those graphical characteristics, we should be able to figure out what our limit value is. Again, this is only for the left and the right, okay, negative infinity and positive infinity. So we're going to be kind of big boys and girls today, and we're going to take away the graphs, and we're just going to look at the equations. I know. Okay, so let's see, zoom in. Take a look at number 1. All right, can we classify, is it beginning as growth or is it beginning as decay? What should we look for? What number? The base. 2/3. Okay, so is that initial growth or decay?
Initially decay.
Initially decay. So we got to ask ourselves, are we flipping that decay? Do we have a flip going on? Yes.
Catch.
Y-axis flip. So if you took an initial decay graph and you flipped it left and right, what would that look like? It's now growth, right? Okay, so this is what we start with. This is what it's turning into after we do the flip. So take a look at your limit. As we go forever to the right, what's our little rough sketch telling us we do? Bless you. We're going up. Positive infinity. Okay, so we're going to draw little rough sketches. Maybe some of you are really quick with these, like you know the patterns in your head, like whether it's growth, decay, if we flip it. So it depends on what works for you. Check out 2. What is this one starting as? Decay, bases between 0 and 1. Okay, so we're starting like that. And what's it changing into?
X-axis flip.
X-axis flip. So still decay. This time we're just underneath the asymptote. So take a look at your limit. We want to go forever to the left. What's our rough sketch telling us we do? Negative infinity. We go down. Yep. All right, these are just for exponentials. Okay, base to a power of x. Check out 3. What do we start as? Decay. How are we changing it? X and Y. Good. Okay, so if we were to take decay, flip it both ways, it would be underneath the asymptote and changes to growth. Good. Okay, so this is a rough sketch. As we go to the right, what's our sketch doing? Negative infinity. Do you guys think you can try the next 3? Probably. Try 4, 5, and 6. Try 4, 5, and 6.
Wow.
Look at our helpful chart, huh? Let's do that. I'll just do it.
Hey, Stu.
Start at growth. Go to decay. Go to decay.
Mic drop.
That is exactly what I said. It's exactly what I said.
Hey, Stu. Stu, where'd you get a pass rail?
We're unfortunately outnumbered. You know.
Come on, you can't be expected to be safe forward.
I was honest.
Are we that good? We're done? Where's good? Okay, what did 4 start as? Growth. All right, base is 2. And it changed to decay where? Below. Good. We had both reflections. Okay. So according to our limit, we want to go forever to the right, which would be what? How'd you know it was 2? That's the constant. Good. That's your asymptote. Good. All right. What did 5 start as? What's E, the number? 2.72, 2.718. Good. All right. So growth changed to what? Decay. We have that Y axis flip. So now it looks like that. Rough sketch is good. According to the limit, we want to go forever to the left. So what's our sketch do? Goes to infinity. That's our limit value. Okay. And then 6 starts as what? Decay. Was it changed to? It's still decay, but under the asymptote. Okay, so according to our rough sketch, we want to go forever to the right, which is what? -4. Good. That horizontal constant value on the end. How do we do? Perfect. All right. Check out 7. What do you want to do with 7? Why? Good.
I'm not, because that's what you tried first.
That's what we tried first, right? Okay. Notice how in 7 we're approaching a number now, not an infinity. So we're not really looking at left or right anymore. We're looking at a specific point, okay, as we come in from both sides. So direct substitution is always our best bet unless we're looking at kind of a left or right hand side. So let's try to substitute in 3. We'll get e to the negative first plus 2. Okay, now this is where we might have to be tricky because depending on if this was a multiple choice question versus a free response, this is what you get when you plug in 3, but this might not be what one of the multiple choice answers looks like. So we're going to have to get good this year with rewriting things to make it look like something else, because even though this is right, this might not be one of the answer choices, at least what it looks like. So are there other ways we can rewrite our answer? What do you think, Griffin? 1 over e plus 2. Okay, so that's another possible answer. They're exactly the same thing, they just look different. Is there another way? Go to Anuj.
1 plus 2e all over e.
All right, so Anuj got a common denominator, e over e, and actually added fractions together. So all 3 of these are correct, but all 3 of these are also possible answer choices if it was a multiple choice. So notice how if you only stopped here and this was not on a multiple choice selection, but this was, you might not make that connection. Okay, so we have to get used to rewriting things if we don't see our answer there. What about 8? What do you want to do first? Substitute it in. It's a number. Okay, so we're going to approach a number from both sides. We'll plug in -2. So our power is -1. Again, this is a possible answer choice. That's what we get out. What is another possibility? Can we rewrite it? All right, negative power, we can flip the base. It probably wouldn't look like that, so it'd probably most likely be 5. Okay, so we will have to use some properties of exponents in the future, but now's a good chance to kind of revisit those. How are we doing with exponential functions? We're done. Okay, go ahead and try some of the homework problems. It's literally 1 page, just the front of it. You should be able to crank it out in like the 10 minutes we have left.